are some more interested users out there. And how many are we today? So Muhammad Kamali is again here, Muhammad Hari is here, George is here, Sebastian is here, Enzo is here, and so we are the same course as last week. I thought that we get 2 more students this week, but I don't know where they are. Let's have a look in the Moodle course in the participants list. We are still 9, and there are some students missing here. 1, 2 are missing. The others 3 actually are missing, so I will tell this to Mr. Heim, and I think he can tell me where they are. So, as I already said last week, we started a little bit slower, and if the students join what I thought about and what I said, we will repeat this week. So, since they are not here, we can go on without repeating. So we start correctly, and we in the first lecture, in the first 19 minutes, we do lots more Kotlin programming, and in the second part we go into Android, and then we start over with the Android programming. Okay, I hope all of you are fine, and then we go on. So last week we just had a little introduction into the Kotlin language. You all are able to produce Kotlin source code, compile and run it, maybe with the IntelliJ IDE so far. That's what we already had. So to get a little bit warm with this programming language, we talked about the main function we have to describe to write. We have the value or variable called declarators. So we do not have the need to write the data type. The data type is coming from the context. It is a null pointer free programming language. If we can have variables with a null pointer, we must explicitly write the question mark. Since this language is compatible with the Java, we can write Kotlin code and compile it for Java Virtual Machine, and use the Java packages as well. So in those packages we find functions and classes and objects which can be null. So when using those, it could come a null pointer into our Kotlin program, and that's why we need those annotated question mark to see, okay, here can come a null pointer actually into a variable, and that's why we have to test if it is not null before we access it. And the compiler helps us. Typecasting is automatically done when we test an object. So when we test the object is a string, maybe with the isCheck, then after this, if this condition will be true, after this statement, the object is automatically casted to the desired type. But to show it, we need classes and objects, and the primitive types where the values do not, that the compiler is seeing what this value here is. And so if it is an int value, maybe with a number 10, it can check that it will never be a string. So this is a theme we think about today too, I think. Then we have Loops. The loops are known really similar to the loops we know in other programming languages. So we have the for loop here, and it is doing with ranges. So this is maybe Python style. The string is in a list of strings, and we can check it, and it iterates through this list. We have int checks, and it uses a range. So this array arguments of string gives us a range through operator overloading. Operator overloading is a feature which comes from C++, and it is a very popular feature, and that can be used for we can use it here in Kotlin 2, and quite a lot. So the switch case is replaced by the new statement when. This is quite comfortable because it removes lots of syntax that we would have to write if you use switch case, and it is able to do type checks. We will see some examples for that. Okay, range operator is creating a range. We can do int checks with a range, maybe for numbers, but also for objects. This is an operator, the range operator. It can be overloaded. You can have objects with ranges, and then take an object A and an object B and say range from A to B, and then you create a range with the desired operator functions, and your for loop can go or iterate through a range of objects. But it must be defined in the range what is the next one. So in the normal numbers, we have always a neighbor. Each number has a neighbor which is bigger than the number itself, and we need this for ranges. So if you can define what is the next greater object, then you have the possibility to create ranges for your class. Yeah, so we can do int checks, or we can negate this keyword with a not in. We've seen examples for that too. So now Abdul Salam Ibrahim, you are new to us. Abdul Salam Ibrahim.
Yes, Mr. Schaller.
Mm-hmm.
Yeah, I'm new. Yeah, I was supposed to be present for the last class, but I will I say I mistook the timing
Mm-hmm.
for the class, so I thought it was going to be in the evening,
Mm-hmm.
not knowing that it was supposed to be in the. So I really apologize for
Okay. Okay. But it's actually not a problem. So
that.
we do some repeats here, and then we go on with examples in Kotlin, and after that we start with the Android. So it's the first lesson Android today. So you did not miss it already.
Okay.
Yeah.
Thank you.
Okay.
Thank you very much.
That's fine. You're welcome. Okay, range operators I talked about. We can have a stepping here as well. So you can imagine we go through this range from 1 to 100, and we do it in stepping 2. So we just have the even numbers, the odd numbers here. So from 1, then comes 3, 5, and so on. So it's the even numbers. Lambdas are a core feature of the Kotlin language. We have lots of functions that work with every object, and those functions accept only one parameter. This parameter is a function body. This is normally it is the parameter for this function here, but we can leave the parentheses away, just write this lambda expression here as the function body, and it gives a really nice syntax. It is a core feature of this programming language, so we have to care about this. Lots of lambdas is the thing we will write. And yeah, it is really nice here using lambdas in Kotlin. They have a good interpretation for their features. Okay, creating instances of classes, so creating objects. We don't need to write the word new, since this is a class name and this is the parameter list for the constructor. We know we want to have a new object of this kind, and that's why the new keyword is not really needed here, because the compiler knows we have to create a new object, so the new is obsolete and we can leave it out. So far, I have to look. Okay, we can go on a little bit. This are the basics, and now we come to some specialties for which are integrated in this Kotlin language. We have a new kind of class called data class. So if you create maybe a class person, which just consists of some attributes, maybe a name and a surname, we can say this is a data class, and for this class the getters and setter methods are automatically generated. So it is a little bit code generation. We just say, hey, I don't want to write getters and setters on my own, so I just write the keyword data in front of this class and say, okay, I want to have getters and setters for all those attributes I'm written here in the constructor, and then I have just a single line statement creating me complete class, able to create objects and to handle the variable access. It's a really fine thing. If you think about the need of data classes, we have it quite often, always when we communicate with some database. The data from the database, if we bring it into our software, we need some data classes which accumulate those fields here, and then we have to write them by our own. The IDEs help us. Maybe Eclipse is helping us. When we do this in Java, we can go into the class, right-click the class and say create getters and setters, and then we choose the attributes we want getters and setters for and say okay, do it, and then it is generating some code. So this is the case we can do it in Java with the help of the modern IDE, and here in Kotlin we do not have the need to do this with the help of the IDE. We can do it with the help of the Kotlin compiler. We just say data class, and we get the methods from the compiler created automatically. If we want to use this feature, just write data in front of the class. You get getters and setters automatically. Parameter requirements are really nice. We have, in Java we have positional parameters. So if we have a parameter list which is not empty and which has more than one parameter, we have to put the correct parameter in the correct position in the parameter list so that we can use it afterwards in this method or function according to its position. So parameter A must be in Java in the first position, and this will be then the value for A, and in the second position B maybe. So if we have the same data types, we could switch them. Okay, we could miss the correct position maybe. But if they have different data types, we can't change the row. You know what I mean? We can't change them in their position in Java. So, and here we have both possibilities. We have named and positional parameters. This is a mixed approach. We can just use them as we like it, or as we know it from other languages like Java. Just use it like they are written in the parameter list here. So the first value is an integer and the second value is a string. Then this will be the positional parameter list. But if we want to change, if we want to have the string first and the integer in the second place, we can do this via the naming. So since those parameters have names, this parameter is named A and this parameter is named B, we can change the positions of those parameters when calling this function. Yeah, this is interesting. Let's make an example to that. So let's make some examples. We have this funny function, so the keyword here is fun. Maybe in other languages you know the keyword function, but it's really long, so we just make it short. Fun is also acceptable. This program is a simple main program giving here hello world, and we get a warning that we do never use those arguments. So if we do not use those arguments, we could say leave it empty, and this main function will start as well. So we get the hello world and we do not have a warning here now. Okay, let's say we have a function, another function that accepts two parameters. So function do something, and we do it with a parameter a, type of integer, and a parameter b, type of a string. So I have to make this double dot. This function returns nothing, so we just have to do anything with those values. Maybe print it, print a and b, but a has to be a string, so we can print a with this notation and b too. So it's, or print a line, just print a line. This is only a simple approach. We want to show that we can do something with a number 5 and the word 5. We can do something with b is 5 and a is, or b is another name, 3, and a is 3 too. That's possible both. So we just write only one, we define only one function, and we say it accepts those parameters. You can do what you want, but just give us at least the names. So if you change the positions of the parameters, give us at least the names, and then we can call your function. So you see, the positions are correct. In the print line, we always see the integer number first and the text comes second. And this is a very nice, a real nice, helpful feature. And the next interesting feature is we can give standard or default values for those parameters. And if a parameter has a default value, we can leave them empty. Parameters with default values can be left empty. That's why we have now several more possibilities to call this function do something. So I could call it with a 5, or I could call it with 10. But now you see a is 10, it's positional. I have to give b is 10 and leave out a. Without a name, we switch back to positional parameters. So the first parameter must be integer, and if I leave the name and give a string, he does not search where is the first string in my positional parameters list, and this should be then the first one, which is a string. Maybe could be another solution, but this compiler doesn't do that. He says if you want to change the row, you have to give the name. And now we see that here we have the 5 and the text is 0, and here we have the 10, the 0 and the text is 10. So now if we count, we have positional parameters, we have named parameters, we have default values and those combinations. So one function or one method and 5 different, one method with 2 parameters and 5 different possibilities to call it. Yeah. If we want to write this in Java, we would have to write 5 different methods. And here we just have to write one. Okay, here comes a question: what's a good language to learn? A good language to learn is mainly Java because of the simpleness, and the compiler is quite well. So if you start learning a compiled language, it's always good to learn, better than scripting. And then an easy language is Java. But Kotlin maybe is as well a good language to learn, because when I started, I learned C, C++, and Java, and that's why I would give you a similar hint to do that. But if somebody starts learning Kotlin first, is also a compiled language, maybe he would see it from another perspective. So could be that Kotlin is as well a good language for entrance in programming. So why not? I think maybe every programming language is good to start to learn. So what else? This was the example for that. I think you see the big advantage of the Kotlin solution for functional parameters. Then we have character interpolation. You see that here in the example with the $sign. It is a feature you know maybe from PHP, a language which does the same thing. Here we have strings, and in these strings we can use the $sign to say this. The following names a variable or value, and is set here, is replaced with the value of this variable. This can be done for simple variables, and if the expression is more complex, we have to write it with parentheses. So print line. If we have a name, could be a value, name Kotlin, then we can print line hello name world. It will replace this string in this string here, and then we get it complete. Really simple approach. But very nice, because those spaces between words are now not more the problem. If we think about how would we do it in Java, we could do it like this. And then we have to care about the spaces. Here must be a space, and there must be a space, because if I append those strings, concatenate them together, I want to have spaces between the words, and I have to do them here and there. I can't use those 3 words and concatenate them together, or I use spaces as a sign, a character. I could use this as a character like this, and then I can say space plus name plus space plus world. It's the same thing again, but it's not so nice. I think best approach is leave this out and write the name. Here you maybe see it is more in the direction of scripting languages. This is a thing you find in many scripting languages. You can just create strings in this way, maybe PHP. Good. Next, the type checks. With the when statement, for this statement it is better to have real objects. So since we already used primitive data types, this type checks won't work so good because we have no alternatives. But if we use objects, we could have alternatives and do type checks here. If we have maybe parent classes and child classes in a hierarchy, this could be easy. But here is the is check. So when X is type of A, it is smart casted to this type, and then we can do this expression, or we can run this expression. Or when X is type of B, we can run this expression. Otherwise, if it is whether or not A or B, we can do this expression. And this is really nice approach. Here we get it additionally to the normal switch case approach. If this is a number, maybe 5, we can write maybe a variable number, maybe a size value, and we can write just the numbers it can have here. So maybe I can do a small example with the switch case approach. If we have a variable size, it has the value 10 now, and when size, you know this, we can write 1, and if it is 1, we say maybe 100. If it is, or we give a name, we give it a name. 1 is George, and 2 is Enzo, 3 is Muhammad Hadi, and so on. Then we can just iterate over this size. Maybe I take here the number, I start with 0, and then I go over size values. I could write size in 1 to 5 and print this when statement out. So therefore I need the else branch. This is the last thing, else other good guys. The other good guys, or the other good guy, so the other good guy, and then I can run it, and we should see the text. Here we see it. Maybe I do a print line, then it is more easy to read. So it is going through from 1 to 5, and then we see when it is 1, we get this text. If it is 2, we get this text, that text, and else we get this text. If we want to use this with the return value, the when statement has a return value. This is also very interesting solution. Last week we've seen that the if statement has a return value, and we don't need this ternary expression. And here in this approach we have a return value for the switch case or the when statement, and it is only possible if we have all cases here, or if there are more than those cases possible. Since this is an integer, we have very many cases possible, so we have to define this default or else case, and then it is complete and we can use it with return values. If we don't use it with a return value, if we just want to do it like this here and make a print line in the statement in the when, we don't have to need the need of those else case. But now I have to write 3 times this print for the names. Okay, and this, the other guy is not printed. Now we have it here in one row again. Questions to that? Does anybody want to ask something?
I have a question.
Yeah.
If we have two statements or more, how we can do it? For example, after one case is one, uh, we have three or four more statements.
I did not understand so really. What do you mean with more cases? We have 3 cases here at the moment.
I mean, if the case is one, we want to have two statements. For example, print something and do other things.
Okay. We can use a block. There's no problem. We could use a block here and do more things. We could call a function. We could do whatever we want here. So you can follow a block.
Oh, thank you.
Yeah.
The same in Java. We could add block and with a semicolon at the end, but here just with enter new statement in the block. Yes?
In Java we have switch case and we go into the case and run until the break.
I mean just for extra statements.
So yes, yeah, that's right. If we want to have more statements, we can do a block somewhere in Java too. That's right. Yeah. Just do a block, and then you can write lots of statements. And in Java, you have always the possibility to annotate your block with static, and then it is a static block. But this is not the approach here. We just can say, okay, we want to do more things, do it like that. Yeah.
And the same in Java for one line statement, we don't need the block.
That's right. That's right. Yeah, that's correct. That's correct. Yeah, if we just want to have one statement in a expression, we don't, where a block is possible, we don't need the block for one statement. It could be the for loop, can be the if statement. Maybe there we can do this as well, but not in the function body. In Java, for the function body, we need those braces. And here we will see it. We can leave them. No, we just. You can speak.
Okay. Because as it for the for loop, so I noticed that there weren't many parentheses, curly braces, like to take in the when. So we necessarily don't need to actually use curly braces for a for loop.
That's right.
Just like a Python where you just indent. So, but in this case, you just call the next would I say things that you want to do within the for loop without the curly braces.
That's right. Yeah, that's right. So this when statement is the only statement which is in this loop, and the loop header then iterates and repeats this when statement. Okay, fine. Then let's advance to the next slide. Also specialities. We have a countdown possibility too. So in the for loop we can go from 10 down to 1. So does not have the need to count up like this one. We can use, but then we should start with a greater value than 5. So 10 down to 5 goes down from 10 to 5. So don't call it size, I call it I. And it should work. So for the for loop, it is clear that this value, this I, iterates through those values. Can't be a value, must be a variable, so we can leave out the word variable. Don't have to write this here. It would be an error. So down to is this one goes in the other direction. Okay, the collections, like you know them from Java, are very easily usable. We have functions called, or constructors called list of. Those methods construct as a list, and it just makes a list from those values. We can iterate with a for loop through this list with this for each. The same with a mapping. To build up a map, we can say map A to 1, map B to 2, map C to 3. A map is created, and what's new is a really nice thing. We have associative indexing for maps. So if I want to have the element with a key number C, which has value 3, I can access this value through the key. I can give the key in any type it is. So you see this is a type of string, but the key could be another object, any object you can think about, which we can use in a map, and it can be any. So we can have a object here in those brackets, and then it is searched in the map, and if it is there, we give it a value, and if it is not there, it will be created, but if and only if it is a mutable map. So if the map is not mutable, we could never assign any value. So this is only worth for mutable maps, and if the key is not part of the map, it should be created, and after this statement we should have a key with this value. Maybe we make an example to that. So it's a really interesting thing. Mapping some object, I make a map and say this should be a mutable map. So I make mutable map of, and this is then maybe a name, or A is 1, like in the example, B is 2, and C could be 3. So we map string to int, and what does he now want to 2, yeah, A to B, not double dot, and C to 3. We can use it in a for loop too, but we get the entries. For entry in map, print line entry, we get the entries from the map, and you see it's quite a simple language. You just imagine, what do I want to do, and I can describe it. If I say for entry in map and print line this entry, and the compiler says okay, I can recognize your statement, I can compile it to some beautiful code, and you can run it. It's really nice. And if we want to have another element here, maybe D with a value of 4, I just put it into the map. So it is something like scripting. You know those things from scripting languages. Think about JavaScript, think about maybe PHP. So in PHP we have those statements too. Similarly, because we have associative indices for arrays, or maps, and then you just write this code and you get the value, but this is compiled code, and the compiler checks is a operator overloaded, and for those mutable maps, or for those maps for all collections, the operators are overloaded. We can use them. It is calling a function in the background. We just take the object of the map. So in the background there is a function map set d to 4, or put d to 4, or whatever, set anything there. It is calling a function, and in the function there is the logic, and we can overload those functions, and that's the way how we overload those operators. And for the code, in the source code, we just have to write those small statements here, or get new objects or new keys, new entries in a map, maybe here. So you see D is 4. It has accepted this. Yeah. Really nice. That's this one. And next is the null check, the null tests. If a value may be null, we could create a value which can be null. Maybe we use it in a function. In a function, we could accept a string named name is a string but maybe null. Could be a string which is null. So the print function is also a function which is accepting strings that may be null. If those strings are null, it prints the name null. I could now test with null, and it prints the name null. So if we do want to have a output like, if it is null, we want not read the word null, we want to read the word false. Maybe we could test it if name is null, print and it is not written is null like in the database. If name is null, we ask after the question mark, name is with the else operator. If name is not null, we do this one. We print line name, and else we print maybe false or wrong. Then we could print this statement like that. Wait, this is okay, and else. Is it a else? It's not a double, that is a... What is it? Not a else. Oh wait, name... And then it gives name or wrong, so that's right. I think that is right, yeah. If name is not null, it gives name automatically, and if name is null, it gives wrong. So we don't have to write like the ternary expression in Java would be name is not null, question mark, then we give name, else we give wrong. This would be the ternary operator in Java. We could write it like that. But since this is a null test, the question mark just tests on null, and if it is not null, it gives us name. So we can reduce this piece of code to one question mark, which says make a null test with the parameter name, and if it is not null, give the parameter itself back, and if it is null, give the alternative back. And that's very simple to write it like that. Now we get another text for this null gives now wrong. Another thing is the length of the name is, and that we could do like that. Name has a length attribute, you see name length, but we cannot access length since name could be null. So in our test we give null value, and if we try to access with this operator this object here name, which is an object, we crash our program, and that's why we have to write question mark there too. And then this operation is just done when name is not null. So I mark it with a print line. Yeah, that's getting null in this. This evaluates to null if we give null, and if we give a string, maybe this one, this is an empty string, this gives us a length of 0. This string has 0 length and there's nothing in it, so we do not see the text wrong, we see the text which is in the string name, and the string name is not a null pointer, so we see the length actually it is 0. Now our function test is null pointer safe, and the compiler says you have to test it. You can't use it without testing. So println accepts strings which are null. That's why we can give it to println in this way. Println must be a function which accepts null pointers and prints then if name is null, it prints this word. This is what println does. So that's actually the statement in println. The name, or this expression, gives back the name if it is not null, and if it is null it gives back the string with the word null, and this is what you see when you print a null pointer. Yeah, so that is the solution of the println method in Kotlin here. Okay, so far. So that's why I changed it to wrong, that you see what happens in println. And if we want to access any object which can be null, we have to save it. We have to save this access operation against this possibility that name is null. And the compiler, what does the compiler do? The compiler does if name is not null, we do this, else we do something else. Else we print the word null in this case. So another thing is, I also mentioned, if we do a null check here, we can leave this null check here. So if we do it here, the compiler recognizes that in the body of this if expression, this variable can never be null, except I give it a new value. Maybe a return value from a function which could be null. So if a function has a return value that could be a null, maybe a Java function, then the compiler also recognizes, okay, the name could be null again, and then I have to null test it here again. But if I don't change the value of the name in between those two statements, the compiler recognizes that and says now it is safe to use the length attribute of the variable name, because name is not null. This is very, very nice. This is really nice. In Java we would have to write this like that. So we should write it like that to make it safe to access this attribute. Because in Java every parameter which is a string can be a null pointer. So we are not safe against null pointers in Java. But here we are safe. You see, we have to especially allow null pointers. If we don't use it, there can never be a null pointer in here. We can never write test with a null pointer. So this code is not wrong, but it is not needed anymore. We are not allowed to write this one. This is now an error, because the function test does not allow that we give it a null pointer to test if our function works properly as well on null pointers. And this is a really good advantage. So if we program normal as we are doing it in Java, we cannot run in the trap to access null pointers. The null pointer exception is eliminated. Yeah, it is quite well eliminated. You see this? I hope you all recognize it. Okay, good. and this is a really important advantage. So you see the short form is here. Just check if name is not null, and if it is not null, we can access this attribute or method. We don't actually see if this is a method or an attribute. Could be both. And then we have here a similar approach with an alternative. This is without an alternative. The alternative is null, and println accepts this null value. And this here, if this gives null, if this is not able, this length attribute, we get an alternative, and this is the string 0, maybe the string with null. Yeah, we can add it to our function. If we go back again to the Kotlin solution of this null check, so use the question mark. If I append the Elvis operator here, so I do another null check. If this here is not possible to access length, because this here is null, this expression gives back the value null as well. And if this is null again, I get returned the alternative, and this is a string with the 0. Yeah, I could here write 0, 2 or small letters. I must use null as parameter now. And then I get it here. Okay. Questions so far? So if not, we can use a lambda function body, and this is a lambda function body. This is a function which runs this body. This is a really simple thing. Just use this object and run this body within this object. And this body or this function is only executed when the value is not null. Really nice thing. So we will see later some more and learn some more about let and run. So let and run are two similar things. They work with the actual object, and the question is always, do I have this pointer in this body or not? And we will see how it is defined when we learn a little more about lambdas in Kotlin and extension functions, because this here is a extension function. It is appended to every class you write, and then we have let for every object we want, and run as well. So it's another approach is the extension function run, similar to this let, and we can run it with the actual object and do something with this object. It's a really nice thing. It is maybe like a JavaScript. So okay, these are the Question, please.
No, I was wondering that Kotlin seems to be a revolution in easing the statements. I was wondering why such a language has not happened before.
Yeah. That's right. That's correct. You're really right. So it is just a.
I mean, if it is possible now, it would have happened before.
That's right. Yeah, that's correct. Why it was not invented years ago? I can't really tell you why not. But the a invention of a new programming language. How does it go? How did it go with Java? When did Java? Where did Java come from? So it came out of a project. It was a idea of a development team, and there are normal tasks, and they have to earn money. So they have to do projects, and they have to sell products. And there is a company which has the need to do projects and earn money and so on. And that's why it is not so easy to say, okay, I do a new programming language. This is nothing you earn money with. Oracle bought this Java now and tries to do a commercial, semi-commercial outcome or a product. So tries to sell licenses and says, okay, we have support, and tries to sell support. But normally, if you look C, C++, Java, the open Java, normally a programming language is open for everybody. Everybody can learn. Everybody has access to documents. You need to have or build up a community which loves programming or likes programming and helps you to develop your programming language. You can never do it. You can never do it alone. Programming languages are too smart and too big. You have so many hardware to support and so many things. So it is a very difficult thing to do it without earning money. You need much time, but you need to have something to eat. You need to feed your family and so on, and that's yeah. So that's maybe a reason why it takes such a long time to say, now we take the money, we have enough of that, we use this team which is building up the IDE from JetBrains, this IntelliJ, and we just do a new language. So it's maybe something you can do in a university if you have a group of students which is working over years on a new language. And or more universities together, then I could imagine that this will go. But that's maybe a reason why many people have ideas how to do it a little bit better and how to make it easier, and everybody for his own. But nobody has or invests the time and the money to realize this then. Yeah. But now we have some nice thing, really nice.
Sure, thank you.
You're welcome. Okay, this was the introduction to Kotlin. Now we got a fast view on all the topics which are highlights of this language, and now we go a little bit deeper into and review the details. So one thing which is a little bit new as well syntactically is we can use the underscore in numbers. So if you write really huge numbers, this could be banking account numbers, credit card numbers, this could be lots of bits and bytes you write, hexadecimal, binary, or decimal, long and integer numbers. You can use the underscore to make it better readable. So you see here, we can simply see this must be 1 million. We do not have the need to count the zeros with the finger and say 1, 2, 3, 4, 5. Oh, am I wrong? Again, 1, 2, 3, 4, 5, and so on. So you see it on with one eye catch that this is correct 1 million or credit card number. You can have the 4 blocks here and binary numbers as well. So you do not have to write 32 bits in one row. You can write it now byte-wise, concatenate with the underscore, and the compiler says, okay, this is this belongs together. It concatenates it to one number, it compiles it to one number. What we do not have is a octal approach. We have no constant, no literal that is realizing any octal representation of a number. Is not more in Kotlin. Only hexadecimal and decimal and binary is here. Octal is out. So since we have a virtual machine in Java and in Kotlin 2, I think the data types have fixed lengths. And as if you already programmed C or C++, you maybe know that the compilers have different sizes for their primitive data types, and this belongs to the possibility or to the capabilities of the hardware, of the machine, of the processor. Has the processor a 46-bit architecture, or has it a 32-bit architecture, or is it a 16-bit architecture, and so on. And then we have just smaller types. Maybe int is 16-bit long, and this is the least size integer should have, and long is 32 bits long, it's the least size a long should have. But here in Kotlin we have fixed sizes, and they are the same as in Java. So there's nothing new. We have the same sizes as we know them from Java for numbers. Okay, let's do some interesting example. Maybe we do some example with those numbers. What could we do with that? We could write some loops and try to give a character or string in the Unicode. I'm not sure how I did it. I did it before. I prepared this, but I'm not sure at the moment how I did it. So I took a 2-byte number. Maybe this is an integer. So I take an integer number variable, a character or a letter, and it starts with the value. I just try to use the ASCII code. I start with 0, so this is 1 byte 0, and I can go through the next 255 values. And this 256, just print the letter, but not as a number, so not as a number, as a character. So letter to char should be a character. Wait, I think characters are 2 byte 2 like in Java. Let's take a character. Letter should be a character. And then this is possible, and we want to append 1, we want to call it up. So let's see what it prints. We see here actually the ASCII code table. These are our signs. ASCII is not 265, it's 128. And we start from, yeah, this is better. We start from 0 to 128 and show those numbers. So now we have printed the ASCII code. We can say, okay, this is 2 bytes. This was what I used until now is just 1 byte. We could say, oh, let's take some 2-byte signs, and those are Unicode characters. I could say, okay, in the Unicode we have maybe C from C0 to 1. So maybe I might make it a little easier if I say the letter is here, and it goes from 1x00 to 1x, and 128 is is 8, like this. Should be like this. So we don't have the need to do plus plus. We can take this away. Then we have, I think, the same here in the loop. This is the same. Now we make another one and say, okay, let's look into Unicode. In the Unicode we have maybe C0 to 0100. What is in this range of letters? What do we find? Which letters do we find there? I take this away. Just save it. Run it again. We have here German umlaut letters A, Ö, Ü, and small ones called Ä, Ö, and Ü. And you maybe see some letters from your language too. So we have here letters with these accent aigu or accent grave on it. In the European code page, do you have a question?
No. I'm just the like the letters from with division kind of this thing. It's also in my local language, Africa. So yeah.
Okay. You have Africans. Okay.
Yeah.
Do you have a code block? What do you have?
No, not really. It's most of the characters are also here. So like from
okay.
so
They are similar, so you see.
yeah, very similar.
Very similar. Oh, nice, interesting, very interesting. So I have some other code blocks. Maybe we have here. So Indian students are not here at the moment, so they are missing. So maybe someone of you is from Iran. We have here the Persian code block. It's part of the Arabic signs. It starts from 06, the first byte is 6, then 20, and goes to there. They have 32 Persian letters there. 32, just add 32 to this number, so 32 is 06. The first byte does not change, and the last byte takes 2 more, so it should be 4, like this. Let's have a look what comes now. So now we have those letters here. I can't read them, but maybe there are people here, students here, can read them. The Arabic code block is a little bit bigger. It is starting from 600 and has 265. um, letters and contains, so far contains this Persian alphabet. That's much bigger. You can imagine that it is really huge. But at 265 is okay. The Chinese have more, I think. And the Indian guys have, but they are not here, but I have prepared the statement as well. They have their code block in the 09, and it goes to 16 times 8. So we have 80, and then we have 6 times 8. We have over 100 more, so this is going to, I think, a somewhere like this. This is now 255 2, but maybe we don't need so much. I think it stops somewhere here. So here we have letters from the Hindus. And this is Unicode and all those letters in Kotlin in Java 2. So we have 2-byte Unicode letters, and we can use the complete Unicode character set. And I think for every one of you, if you are interested in, just find out in which part of the Unicode you have your special code block, then you can use those codes from there for your special signs. It is possible to do in Kotlin, to do that in Kotlin. Another thing is we should care about a. If a is an int, we can write it like that, 10,000. And if we print that a is equal or identical to, you have this identity check. And this is true because a is identical to a. But if we do a little boxing, a boxed a is an int which can be 0. This can be initialized with a. So you know, automatical boxing in Java 2. In Java we have the approach, we can use the primitive integer type, or we can use the class type of integer, and it's the same. So it's not a real object type because it is automatically boxed or unboxed, and the integer is normally a value type. But here in Kotlin this is not the same. If we do another boxed a and say this a as well, and try to check if those are identical, we find it is not identical. So the boxed a is not identical to the other boxed a. Fails. These are two different objects. But if you use the normal equal check, like we know from Java, it will not fail. This returns true. The identity check is only is checking the identity of objects, and the equality check the equality of objects. So if one object equals another, it is using the equals method. Using the equals method, doing identity check, so checks the references. And that's why we have two different objects here. Both have the same value. So if we do the value check, the equals check, it is the same. It is true. If we do the identity check, it is not the same. Different objects. We have the same value in two different objects. That's what the message is. And we can test both with those operators here, and I think there are several languages who do this in the same way. Maybe PHP or JavaScript or Python too. I don't know if Python does it too, with the 3 equal signs here, this test. It's the identity check. And it's possible to do in Kotlin too. So what else do I have to numbers? Or primitive data types, we can, or it is not possible to implicitly extend the values. If I have a byte, this byte is not implicitly cast to int. In Java, typically lossless conversions, the smaller type, the smaller integer type, can automatically be cast into a longer one or bigger one. In Kotlin this is never done. In Java especially, we can cast automatically integer into float, but not reverse. And this is in Kotlin also not automatically done. So in Kotlin we could try to, in Java we could try to use a floating point variable. Var is a real number from type float. All data types have big names in Kotlin. We do not have the primitive types. We only have objects. So float is just the class name float, and if I give it a integer number, it is a arrow. You see this. 4 is a integer number. This is a integer literal, and it does not conform to float. Does not work. So if I want to assign this integer number to this float value, I have to cast it explicitly, and the cast is done via an extension function. It's called toFloat. And then this is a float. So make a float out of it. Say it should be a float. Make it toFloat. All primitive types can be cast into every other type with help of the toType methods. All primitive types can be cast into any other primitive type just with the help of the toType cast method. So that's why we could do a integer. So how's it? It's the English word natural number, and it is a int this way, and we make it from the real we can say to int again, and finally both should be or should print out the values. Yeah, you see 4.0, this is the floating point expression here, and this is the natural number 4. Both have the value 4. We casted this integer, constant or literal to the floating point data type, saved it there, and then we cast the value back. This is not gone automatically. It's not done automatically. Okay, but we have those two type methods, and we have them for every basic type. So if I do 2, I can make a string, a short, a long, a int, a float, a character by double from this one, and the same from this real number. It is only explicitly done, so the implicit type changes are away. Another example I have here is take a long number. It's 1L, so 1 is a from data type long. This L appendance or suffix here says that this integer number is from data type long. It is a really long integer number, and we append, we sum up the number 3. In this case, the long plus int will be long, so this plus operator casts this value to the desired type long, and there it works like we expected in Java 2. So this number will be the same type as this number, and this is the bigger type, so this one will be expanded to a long. Then we append, we sum those two long values and get the value long 4. So this is then a long value. I can't assign this to my natural number. This is now this is an error, because here we have a long and here we have a int. But if we want to do this assignment, I have to cast the long to an int. The other way it will not work too. So if I say the long value the long variable shall get the value of the natural number, it won't be automatically expanded to long. To make this a long value, I must cast it, and the other way too. Let's have a look into the chat. Maybe there's something. Okay. Questions so far? Okay, that is this one. We have no implicit type extension. Now we have just 5 minutes left, but let's have a look to the next. It is not so difficult. We are within the basic data types. According to number types, we have character types. Characters are numbers. In lots of programming languages, characters are similar to numbers. So the data type character, or char, is a number, a integer type, and is handled like a integer type, can be automatically cast into integers. and if we add two characters, the outcome will be a integer value in Java maybe, and here we separate those data types. Character types aren't compatible with the number types, or are no number types, not automatically, and this is a result of this approach here. We just have to explicitly cast values, and we can cast to character as well. So all types are really implicitly separated. We have no implicit type conversion except the what I've shown here. When the sum is coming, then this 3 is automatically made a long value, and if I say this is like that, then here is the next problem. I have a long and a double, and I cannot add both. I have to either make a integer number from here, or make a floating point number from here. So, and that's the reason why characters aren't numbers anymore. We have the Boolean data type, and we have the operators with the Boolean values. This is the logical and logical OR and the negation operator. You know all of those. We have arrays, and arrays we can use with the get, or we have a get and a set method, where we can ask for the value according to an index. We need the index to access the array, and if I use this get method, it will be an operator. This is especially, or these are the operator methods for the brackets to access the array variable. And we have the size. So all arrays have get, set, and size, similar to Java, but the arrays are objects, and they are in size constant. Yeah, that's what we have. And we have the library function array of. This function creates arrays of variable arguments. We just write array of, give a list of numbers, and then we get an array. Additionally, we have a constructor for the array class. So we write the class name, not the helper function. This is a helper function. We can write the class name and use the constructor. The constructor accepts a lambda function. We can give a initializer lambda function to initialize the array. We just have to give the size of the array. I want to have 10 elements, and then I say I give a lambda, and this lambda function is looped in a for loop, a counting loop through all my indices, and then I can access the array element and say you get this number, you get that number, and so on, or you get this object or that object, and initialize all my array elements. Really simple. I could give a simple lambda which says all elements should be null. Then this lambda just consists of a null value. I think we make a example, and then it's break. So special initializer or special classes derived from the array class are the primitive data classes, int array, byte array, and so on. And we have the helper functions to every class. This is array of the helper from the array class, and for the int array class we have the int array of helper function. So let's see our last example for this lesson today. I make a array from array of, just say I want to have in my array 1, 2, 3, 4, and 5. Print this array. What is it? And we see it's an array, not more. We see the same as we see it in Java. We see it is a array. That's why we have this bracket here, and it is from type integer. And in Java lang integers, you see Java lang integer, it is the Java language type, and we have a reference to this array. So if I want to see the elements of this array, I should use a loop, any loop, maybe the array dot for each loop, and here I can print it, and this prints my array. This is the array of approach. Another approach could be to define the array with the help of a lambda. Then we use the array class and say we want to have a array of int 5 should it be, and the lambda sets all to 0. Now we have a array with a lambda creates 5 elements, all are 0, and I could say all are the index, and then we get it from 0 to 4. And if I want to have it from 1 to 5, I just say index plus 1. And we have our entrance example again. So I write array int, and the alternative is to write int array. It's the same solution. Just it's just a derived class here from the array class with this template type, and the template is then interpreted as int. And yeah, we are over the time. Okay, this is the place where we jump in next week, and you are more interested in Android, so let's have a break, 15 minutes, and then we start over and introduce Android. Some of you already programmed for Android, and I hope you, or I think you already used Kotlin 2. So for the others, it is no problem. We start and go a little bit into, but in 15 minutes. So now it's 18, and in 15 minutes we have 33. So 3 minutes after 11:30 we begin the next lesson. Until then, you have a break. See you.